Good morning, all of you. In this class, we are discuss about the octal to binary encoder. This is one of the type of encoder. We can say that last video we have discussed about the types of encoder. In that we have discussed the types of encoder. The first is priority encoder, then is decimal to BCD, octal to binary, and hexadecimal to binary. So out of which today we discuss the octal to binary encoder. So basically this octal to binary, the word itself says that octal. So octal for 8. So that's why we can say that your convergence from octal to binary. First of all, we should know about the convergence of octal to binary convert. So here octals, this is a block diagram of octal to binary converter. So here the octal to binary encoder is a block diagram. In that case, if you see here in the input side, that is D0, D1, D2, D3, D4, D5 up to D7, that is the input as 8 bit, that is for octal, and here binary. So to convert from octal to binary, we have used that particular block diagram. Now in that second, this is output case, and the right hand side, this is the output side. So here why we are going with the 3 binary number or 3 bits, that is output. So we are having with again the relation, that is n is equals to 2 raised to power m. So suppose we are using the 8 as a n input, so is equals to 2 raised to power 3. So by using this, that m is equals to 3, so output, this is what your output basically. Yes, so by using this relation, we can say that we are having with the 3 outputs. So this is what your octal to binary encoder. Now we are having with 3 output called as y0, y1 and y2. y0, y1 and y2. So by using this block diagram, we have to just draw the functional table. That this is what called as a truth table also. So this is what functional table or truth table for this octal to binary encoder. Now people, this is also called as 8 to 3 bit encoder. This is what your 8 to 3 encoder also. This is also called as 8 to 3 bit encoder. Okay, this in our previous video we have discussed about that 4 to 2 encoder also. That is introduction to, whenever we have discussed that introduction to encoder and decoder, that video we have discussed the 4 to 2 encoder, and this is basically 8 to 3 encoder. So in that we have discussed, that is what your function table. So that function table start with your number, that is 0, D1, D2, D3, D4, D5, D6 and D7. So for that we have drawn this truth table. So start with here that D0. So as a definition or the statement of this octal to binary or encoder, we people know that at a time only the single bit or the single input is to be high, or we can say that active. So for this, if suppose the D0 is going to be high, so in this case as D0 is going to be high, so that 0 0 0, we get the output here 0 0 0. Yes, as same as if D1 is going to be high, so we'll get the output at 0 0 1. Then D2 is going to be high, then we'll get the output 0 1 0. Likewise for your D4 is going to be high, we'll get the output here 0 1 1. So here we get the output as 0 1 1 for your D4. This is what your D4. Next what your D5, D5, D6 and D7. So in this way we are having with D0, D1, D2, D3, D4, D5, D6 and D7, and for that last D7 we are having with the output like 1 1 1. Okay. So by using this block diagram, we have to just draw the functional table or truth table. Now for that we have to just go with equation. Now the last or the main motive is to what? We have to just draw the combinational circuit diagram or the implementation of this octal to binary encoder. Now we have to just write down the equation for this y2. So first y2 is equals to, now here the 1 here the 1 is for here, here, here and here. Now the 1 is for your D4. So here the D4, basically this is what your D4 plus, now here the OR operation is going to be performed. D4, D5, D6 and D5 plus D6 plus D7. Next Y1, we have to just go for Y1. Now here Y1, so D0, D1, so here what your D2, D3, so this is what your D2 plus D3 plus D0, D1, D2, D3, and this is what your D6 and D7. So again this is D6 plus D7. Next Y0. Y0 is again here D1, D3, D5, D7. So for that D1, D3 plus D5 plus D7. So we are having with these three equations by using this functional diagram or truth table. Now we have to just draw the combinational circuit diagram. Combinational circuit diagram. We have to just draw the combinational circuit diagram for this octal to binary. Now we are having with these equations for this D1, D2, D3, D4, D5, D6 and D7. So for this Y0, Y1 and Y2. So we have to just draw the lines for the input lines for this. So basically start with your D0. So this is what your D0. Next what your D1, D2, D3, D4, D5, D6 and D7. So we have to just write down the terms we are having with that D0, that started with D0, D1, D2, D3, D4, D5, D6 and D7. Now we are having with this input line. So draw for this. First is for your Y2. So Y2 is D4, D5, D6, D7. So D4, start with your D4, D4, next is what your D5, next is D6 and D7. So here the OR operation is going to be performed, that is OR operation. Next is your D2, next is D3, next is D6 and D7. So here the second Y1, next is D1, D3, D5 and D7. So basically this is what your multi-input, we already discussed that multi-input. So this is what your multi-input applied to different OR gate, that is first is your Y2, Y1 and Y0, Y2, Y1 and Y0. So this is what the combinational circuit diagram for your octal to binary encoder, or it is also called as 8 to 3-bit encoder. So if you take an example for here, as we apply the input basically for 5. So 5 is what D5. So here we apply for 0 0 1 0 0 0. So here we get the output as 1 0 1. So in this case, if you apply the input for 1, D5 as a 1. So here the input is what D5 as 1. and remaining term is going to be 0. So only term is 1, remaining term is 0. So here, as OR operation, we will know that OR operation is going to be performed. So in this case, D4, D5, D6 and D7. So OR, so 0, 1, 0, 0. So here we are having the 1. Next, it is what D2, D3, D6 and D7. So all the 0. So it is going to be 0. Next, what D1, D3, D5 and D7. So it is what 0, 0, 1, 0. So this is what your 1. So finally we are having with the output that 1, 0, 1. So for this D5, if you check for, so this is what your 1, 0, 1. So in this way we can cross check our combinational circuit diagram also. So this is all about your octal to binary encoder. Thank you.